Okay, so for this week's worksheet, we're going to do problem number 2 on here, which is going to be another optimization problem. And so this one says we want to find the point on the parabola y equals x squared, which is closest to the point 3, 0. So the first thing you want to do for a problem like this is go ahead and draw the graph of the parabola. So we've got y equals x squared. It's going to go something up like this. And we want to find closest to the point 3, 0. So that's going to be, say, somewhere out here. So what you've got is the closest point is going to be a straight line to it. So we'll draw a line that's perpendicular to this graph here. And then you see that this will be a 90-degree angle. And you're going to have essentially a triangle here. Well, what you're going to want to do is when you see this distance here is going to be 3. So you want to drop down, make a little drop down there. And then you've got this other triangle that's split in 2 here. So we've got 3 minus x, because this x is going to be the point that we want. So one of those sides is 3 minus x, and the other side is just going to be straight up y. And that's going to be the y coordinate for the actual parabola. So when we get to this point here, what we're going to want to do is say the constraint is y equals x squared, and then we want to minimize the distance here. So we'll expand this triangle that we've got a little bit. So this is our 3 minus x, because x is right here, 3 is right here on that graph. This is our y, and we want to find the minimized distance d here. So what we look at is that we know the equation d squared is going to be, since we've got a 90 right here, it's going to be 3 minus x squared plus y squared. So 3 minus x, quantity squared, plus y squared. Okay, so we'll go ahead and expand this out. So we get d squared is going to be, let's see, so we'll get 9 minus 6x plus x squared. Okay, and then this one will be plus y squared. Now what we're going to look at doing is say that y is equal to x squared. So whenever we see y, we can just plug in an x squared instead. So d squared is going to be 9 minus 6x plus x squared plus x squared for the y. So we're going to look back, so just to make sure, we get 3 minus x, so 3 minus x, so that'll give us 9 minus 3 minus 3, positive x squared. So now that we've got the d squared, this is basically, now this is our f of x. And we want to minimize this, so we want to set the derivative equal to 0. So when we go ahead and do that, we're going to get, the derivative is going to be negative 6 plus 2x plus 2x. So negative 6 plus 4x. So when you do this, add the 6 over, we see that 4x is equal to positive 6. So x is going to have to be 6/4. Okay. So now that you've got that, what you're going to want to do is make sure that the extremes of your function, the endpoints basically, don't minimize the distance. So you would technically plug in x being negative infinity, and you would get infinity, and you plug in x positive infinity for f of x, and you'd also get infinity. So what that tells you is that this one here is the point that's going to minimize that distance. So if the x value is 6/4, then the corresponding y value, since y is x squared, is going to be 36 over 16. And that's your point that's going to be closest to 3, 0.